Welcome back. We're going to continue quadratics, except now we're going to get into relations a little bit more. And we're going to get into some special kind of formats of relations with regards to these quadratics. Now, if you recall, so the quadratic relation y is equal to ax squared plus bx plus c. We've done quite a lot with that in terms of factoring. We've even graphed it, kind of got a chance to see what the vertex is, line of symmetry. If you want to be able to see all of that, which is kind of the first part of quadratics, we're going to put up a link to the entire playlist so that you can watch it. And then at the end, there's actually a test there as well, which you can go through. Now, this one is going to be kind of breaking down and taking a special format first, which is just y is equal to ax squared. So really, x squared, which is just perfect square, the zeros are just 0 and 0, and ax squared is going to have the vertex at 0, 0. Now, with that, we want to be able to see if we start changing and playing around with our a, what's going to happen to our relation. And we're going to try to do kind of a table of value first, and then we're going to plot it out. We're going to use Desmos to see it. We can, of course, use just a regular graph, which I'm going to do one example like that as well. And first off, if we take this relation, and that means that basically in our general quadratic, that b and c kind of constants that we have are zeroed out. And this means that this is 0, and this means that this is 0. So I'm going to remove these at first. Now in future videos as we continue, there's going to be different formats, but this is going to be our first format. And from the things that we know about quadratics is the first kind of, so I have 4 cases on the right hand side, they're on blue, that you see. The first one is a is equal to 1, second one is a is greater than 1, and then the third one is a is between 0 and 1, and then finally the fourth one is just a is less than 0. We know that for the first 3 cases, these cases, because a is greater than 0, then that means it's positive, which means that our relation, if we would graph it, is going to be opening up a parabola upwards. So we would see a parabola going up. Let's take the first case and kind of go back into some basics and first, do a table of values, kind of see what is happening. We're going to do the plot of it, and then we're going to see what happens if we start playing around with that a. If we're going to make it small, if we're going to make it very large, if we're going to make it negative, what is it going to do to our parabola? All right. Now, if I do this, guess I'm going to take this and I'm going to create a table of values here. I'm not going to make a very long table of values, but let's imagine that we have so we have our input, so that's our x, and then we're going to try to see what happens to our output. And we're going to zero off, so I'm going to concentrate on this case where a is equal to 1 first. That means that I have y is just simply equal to x squared. And let me, so do this, so -2, -1, we're going to put 0, 1, and 2. So if we create a table of values for these, what you will notice is that y is going to be, so here it's going to be 4. For -1, it's going to be just simply 1. For 0, it's going to be 0. For 1, it's going to be 1, and then for 2, it's going to be 4. So we remember that quadratics, because they're parabolas, they have symmetry between along the vertex. So there's a line of symmetry that goes through, and then we can be checking so that basically the values on the right are equal to the ones on the left. And here, so if I plot this out for myself in terms of points, notice that all of this means that these are positive. So I'm not going to really need the negative ones at all, at least not for the moment. So we have that. So here is my x, here is my y. And if I was plotting that out, so notice, so -2. So let's kind of say 1, 2, 3, and these ones are negative. All right, so this is what we have. So at -2, and then I'm going to try to see, so 1, 2, 3, and 4. So the first one would have been right there. So that's the first point. And then at -1, it is equal to 1. So that would have been right here. Then at 0, it's going to be just at 0. And then it's going to be 1, 2, let's say 3, and so on. So that's going to be now 1. And then this is going to be 4. And if I was drawing this out, so what I would get is I would get this nice, beautiful parabola here going kind of like this. Let's see if it, oh, perfect. It created for me. I'm going to try to see if I can squeeze it out. It may not work exactly, but all right. So it's a little bit off. I'm trying to make it and squeeze it in this form. Okay, it doesn't want to do it. Okay, let's see if that works a little better. It's almost there. All right, I think you get the gist there. Okay, so it's going through those points. Okay, so I'm going to go do that. So that's my parabola, okay, which is opening up upwards. Now, if I wanted -3, so notice if I plug in that, it's going to be squared, so it's going to be 9, and so on. That is my relationship between my x and my y when a is equal to 1, which is a nice parabola. So notice the line of symmetry is exactly along the x-axis, and my vertex is basically equivalent to the point 0, 0. So that is my vertex right there. Now, what happens if we start playing with this, and let's say we start making, okay, our a greater than 1. So we start adjusting it. And what would happen to this parabola, right? So what would you think would happen? Is it going to kind of open up more, or is it going to get compressed more? So it's going to stretch, or is it going to compress as a gets bigger than 1? And you can kind of think, right? So for each value that you would have, if a is going to be greater than 1, that means that the multiplication, because now what we're going to be dealing with, you're going to have y is equal to a times x squared. Well, x squared is basically this green chart that you have. And then if you start making this a greater than 1, it's going to make the values bigger, which means it's going to actually compress it and not stretch it. Let's take a look and see. So we'll take a look at some values. So let's make a is equal to 2. Let's make a equal to 5. Let's make a equal to 10. And then be able to see how it looks like. Now, I'm not going to repeat these table of values. I think you get the understanding. It's kind of exactly the same as you would be plotting your regular lines as you did in grade 9 and kind of beginning of grade 10. This is now a tool that we can use, which is Desmos, to try to, speed up the process and then the learning as well. I'm going to plot this out. So here, so let's say x squared. So here is my original x squared that I have. I'm going to bring it down so that you can see it. So that's my original one. Now what we're going to do is we're going to play around with our a. So a is equal to, so I said, okay, so let's double a. Now it's going to be 2x squared. And notice what happens, it actually compressed it in. So that blue is your actual 2x squared. It has the same exact vertex because that won't change because you still have only x squared. There's no other values there. We're not shifting things around. All we're doing is we're just now playing around and we're compressing this in. And as you make these bigger and bigger, so let's say if I make this, notice that green now really gets compressed in. And that again should make sense to you, because imagine if you substituted, if you had x is equal to 1 in the first one that you had, so x is equal to 1, that was just 1 squared, which was 1 for the value of y. So the relationship, okay, was that the point was 1, 1. If you put x is equal to 1 in the second one, notice now that a is equal to 2. So 2 is just going to be multiplying the 1 squared, which is going to be now 2. So it's going to be compressing it in. And then if the a is equal to 5, well, 1 squared is 1 times 5 is now 5. So it really kind of just stretches and pushes it upwards, right? That's what happens there. So those values, so if I would be plotting these in, so for instance, the first one was 1, 1. Notice that's what happened there. But now look what happens if you plug it into the second one. well, now I'm going to get 2. So notice the x is equal to 1, but the points are now just getting, okay, higher and higher because the value of y is getting higher and higher. And then the last one would have been 5. So, you see those points right there. Let me just label them so that you can see it on the screen. So it really just compresses this back in, but then really just stretches it further out, right, as you have the relationship going. Now, you can continue this, right, for a is greater than 1, and then we'll just keep kind of making it narrower and narrower and narrower, okay, as you go through. And of course, you could, if you put it 100 at 1,000, it would just get really squeezed in there. Now, what are some of the other ones that we have? So here, the other case, okay, or kind of the third case within here is this one. What happens when a is between 0 and 1? And that could be anything. Now, because when we had a is greater than 1, it kind of started to get kind of pushed in. It made narrower and narrower. When you start plugging in a is between 0 and 1. Now, of course, if it's very close to 1, it's going to look kind of exactly like this. But then as you make a smaller and smaller, now still of course positive, then what will happen is it's going to start stretching this out. It's going to make it not narrower, it's going to make it more stretched out. Let's take a look and see what happens in that situation. So if I, for instance, had y is equal to, let's put it at a half here, so x squared, notice that's the black one there, and then the original red one that you see is your x squared. So half of it, now it's just made it more kind of stretched out in this direction, right? It pushes it out that way. And if you make it closer and closer to 0, so let's say if I put it at this, all right, so notice what happens there, right? So it just kind of opens up for you. And as you make it smaller and smaller, and let's say if I make it even really kind of tiny, so notice what happens here, right? So these parabolas, I mean, they still are parabolas because if I blow this up, it still looks like a parabola. But of course, in comparison to the originals that you had, it looks much different. And that's what happens between those values when a is between 0 and 1. Now, what I want to show you with the last one, so the last particular case here that you have, is this one, when a is going to be less than 1. Less than 0. So basically what we have is we're going to take all of these 3 cases and make them negative. So let's say a instead of equal to 1, let's make a equal to negative 1. If we make it negative 1, you'll notice that it's going to be a reflection along the x-axis here. So it's going to just reflect right across. Let's take a look at that right here. I'm going to plot it in here. I'm going to make it negative x squared now. And look at that. It just completely reflects back out. I'm going to remove some of these just so that it's not as cluttered. I'm going to remove some of them there. Okay, so we have that. And then let's go back to the original right there. Notice the one in red, which is above, okay, the x-axis is the positive one, and then the negative one just reflects, okay, so it reflects back. And now you would have had the same thing. Now it doesn't matter. So let's say if I had 5x here, and then what you would do is you would have negative 5x, notice that it would just reflect that as well. So it just simply reflects when it's negative. The vertex stays the same, the line of symmetry stays the same, but it's just a reflection and it's pointing downwards. And the same thing happens if you make them, let's say, so if you have 0.5, and then of course if you have that, it's again just a reflection. And with these, it's very good to have that intuition to be able to see what happens. And these are a little bit easier because of the fact that our relation is just y is equal to ax squared. We don't have a bx plus c. When you have a plus bx plus c, you have seen before, those ones are a little bit trickier because when you graph them out, you can still graph them out, but it's much harder to find your line of symmetry. It's much harder to find your vertex. In this case, for x squared, it's very intuitive. You know that the vertex is 0, 0 because x squared has 2 zeros at 0. And so for that, okay, you know then the A dominates and basically tells you if it's going to open up upwards, if it's going to open up downwards. And then what happens? Does it get narrower or does it stretch out fully? That just depends on the value of that particular A, which you just have seen. That's the first kind of introduction to these relations. It's the simplest one. I hope that this has made sense to you, and we'll see you in a future video. All right, take care, everybody. Bye.